So, once again, welcome everybody to this introductory session on SPSS. I think Marla has something that she'd like to say.
Yes. Good morning, everyone. Thank you very much. My name is Merle Massey. I'm the undergraduate research coordinator at the University of Saskatchewan, and a program that we have is a pilot program, the SURE program, Student Undergraduate Research Experience. It's about building skill sets around research for undergraduate students at the University of Saskatchewan, those who are conducting research with faculty members across the university. With us this morning, we have Anna-Maria Bogdan, who is the Quantitative Research Manager and Specialist at the Social Sciences Research Laboratories at the University of Saskatchewan. And with that, Anna-Maria, I will turn it over to you.
Excellent. Good morning, everyone. I'm excited to be with you today. And my vision for these 2 hours are as follows. I would like to start with a very simple introduction to what statistics is and how we go about conducting statistical analysis. I think covering some of the main concepts related to that will help us as we move over to SPSS. The main part of the workshop today will be spent going through understanding SPSS, what its purpose and intended use is, and we'll be working with the demo data set that's already available in SPSS to learn how to manipulate data, understand the different data files that exist under SPSS, and then we'll be working with the data. We'll modify it. We'll try to run some very simple analyses. And yes, as we go through this, I will try to keep an eye on the chat as well. But if I'm missing anything, we can address some of those questions either at our break. I'm planning on having a 5-minute break sometime around 10 o'clock, and I'll try to answer questions as you have. Of course, if something comes up after our workshop, I think Marla can share my email address with you, and I'd be pleased to help you through this. So, shall we get started? I will try now to just share my screen. I'll start by showing you some of my notes that I have here for us today. Can I get a thumbs up or any answer that everybody can hear me okay? I think I can see the chat here. Hear you fine. Excellent. All right. So I will just, sorry, give me just 1 second.
If you see the square and the up arrow, that's share content. So if you just run your mouse over top of your own face, you'll see where it says share content, and then that will work.
Thank you.
You're welcome. Believe me, I had to find it myself.
I guess it's not quite that intuitive. So hopefully you're able to see my screen at the moment.
We can. It has a beautiful mountain scene. There we go. Basic intro to stats. Perfect.
Excellent. That's where I wanted us to be, right here. So as I said, I want to cover some of the very basic concepts that we use quite a bit in talking about data and types of analyses that we do. I think this would be fairly useful for us moving forward. So statistics, a very simple definition that I have here on this slide for you is the science of collecting, organizing, presenting, analyzing, and interpreting data. So statistics allows us to find a rigorous way in which we can go through the entirety of data collection all the way to analyzing that information and then presenting it in in certain forms. So a lot of times we talk about populations and sample, and there's quite a large difference between these. And I'm sorry if these are concepts that you've already, if you're familiar with them. But for the other ones, yeah, I think it's relevant to go over this. So the population, when we talk about the population, we're referring to the entire pool of individuals or organizations from which a statistical sample is drawn. It's a set of similar items or events which are of interest to the researcher. So in order to understand something about the population, however, unless we're running a census, you might be familiar with the Canadian census that is run every 4 years, which is a huge data collection process. That's where more or less the population is being surveyed. So we collect information about everybody who's of interest to us within that group. But most cases, what happens is that we use samples. So we draw samples from the population, and the samples are just a subset of the population, but that subset is collected in using certain procedures, certain sampling procedures that can be either random or convenience type of sampling. Now, there are advantages and disadvantages to each one of these sampling techniques, but, and I can speak briefly to that. The idea is that using the sample will allow us to, through some of the statistics that we calculate, to infer about the parameters and about the population. Using a random sampling technique allows us to do that with more certainty, given that we have enough of a sample size so that our tests have the statistical power that we need in order to make those inferences. Random sampling means that you pick at random individuals from the group, from your group of interest. And there are various variations even within this. It's usually informed by what your main research question is. If your main research question is to compare across two groups, then your random sampling will likely be stratified on that on the variable of interest of which you would like to compare the two. So the other option, as you see here in my notes, is what we call convenience sample, and that's also at times known as snowballing. So we just go from sampling one individual, then that individual might recommend someone else, or it's less of a rigorous process, and hence it affects the types of statistical analyses that we can subsequently run on that kind of data, and the inferences that we can draw back on the population. So the random selection process allows us to have some certainty that we've covered thoroughly the population that is of interest to us. Now, beyond those two concepts, also very important are concepts like cases or observations or data points. And you'll hear me mentioning these multiple times during our workshop today. The cases are the individuals or the actors on which we collect certain data on. So for example, if I'm interested in understanding teaching preferences of students at the University of Saskatchewan, then in that particular case, my observations or my data points, my cases would be students at the University of Saskatchewan. Then the variables are those characteristics that I'm collecting over each one of the individuals within my sample. So for example, I might have questions about the age of students that are part of the USAS community, their gender, their current educational achievements to date, and perhaps income. The variables are usually defined, again, based on what your research interest is. And they can be of different kinds, and they can be measured at different levels as well. And that differentiation is, again, quite important. So whenever we talk about variables, we can talk about different kinds of variables, and we can distinguish mainly between four main types of variables that are measured at different levels. So we can talk about a nominal, ordinal, interval, and ratio level variable measurement levels for the variables. So when we talk about the nominal level or variables that we call nominal, these are this is data that is classified into categories that cannot be arranged in any particular order. So, for example, gender is one of them, and then color, religious affiliation. These variables do not have a certain order in which the different levels can be arranged. A next step up in terms of the level of information that a variable can offer us are the ordinal variables. And these ordinal variables, they can be arranged in a particular order, but the differences between the data values cannot be determined or are not meaningless. And what I mean by that is that we can have, for example, educational attainment, where we can have, let's say 3 levels of measurement. We can have less than high school, some high school, and a high school degree. Now, the differences between these categories are not necessarily precise, as you can note from these 3 groupings that we have here. However, we do have a certain progression that's built into this type of data, the data that we call ordinal. Then another type of data that we typically use is interval data that is similar to the ordinal level data, but with the additional property that has meaningful amounts of differences between data values. So degrees, age, for example, and so on. We do have the difference between one step to the other remains equal. And then we also have the ratio level data and the interval level with an inherent 0 starting point. Differences in ratios are meaningful for this level of measurement. So for example, the number of clients per month. And if you look on the right-hand side, you'll see this diagram that shows these different type of variables together with the level of information that they carry. So at times you'll hear people referring to the nominal or ordinal data as being qualitative data. And then the interval and ratio data is being parametric or quantitative data. And as you study statistics in more depth, you'll realize that there's a large distinction between what we can use non-parametric data with and parametric data. So there are certain tests that we can run on certain types of data. And also the level of information increases with the type, as you see here. So with nominal data, we typically have the most coarse type of information. Nominal data can be dichotomous, yes, no, sort of answer choices that people will have in questionnaires, and subsequently the data that you have. Have you attended school? Yes, no. Then again, also related to education, let's say we ask respondents and we obtain ordinal data, then we can ask them, okay, can you please tell me between these three levels, which one is the one that best represents you? Less than high school, some high school degree. Then you get a little bit more information. It's not only whether they have education or not, you get a sense of what kind, what level of education they get. Now, in terms of interval, you might go further with your question and actually be more precise and ask them about the number of years that they've spent taking formal education. And in that case, you would get additional information about individuals. Okay, this is something that will come up again as we move to SPSS. And you see that in the SPSS, there is a very particular way in which you can define these variables, and the way in which you define these variables is important for the subsequent analyses that you do, or the operations that the system will allow you to do on those particular variables. Okay. Then I guess the other thing that we will be covering today is not only setting up our data in SPSS, but also have a sense of how we can summarize that information. And we can summarize the data that we collect by using some descriptive statistics. And they're used to describe typically the basic features of the data in a study. They provide simple summaries about the sample and measures, and together with simple graphic analysis, they form the basis of virtually every quantitative data analysis. That's our starting point. Irrespective of how complex our models get or our analysis gets, we typically start by exploring the data both visually and through descriptive statistics. Now, there is a big distinction between what we call univariate and bivariate. Again, two terms that you might want to refresh in your mind. When we talk about univariate statistics, we talk about measures of central tendency, measures of dispersion and location for one variable. When we talk about bivariate, we talk about looking jointly at two variables together, and we have different ways of doing that, one of them being measures of association. Okay, as I said, some of the starting points are actually exploring the data, and there are different techniques that can be used to do that. This exploration just allows us to get a better understanding of our data. We gain insights. We can discover certain patterns in the data. Graphically summarizing the data can also help not only understand it, but also communicate it with others and so on. And you have here a graph, and I think I'll leave it more or less here in terms of going over some of these notions. But yeah, in exploring the data, as I said, we can do that in using descriptive statistics, and depending on the type of data that we have. So categorical data here stands for nominal and ordinal data that we discussed earlier. And continuous data is ratio and interval data. So for categorical data, we will turn to frequencies, percentages. For continuous data, for descriptive statistics, we will try to look at means, mode, median within a distribution. If we want to understand the central tendency of that data. Otherwise, if we want to understand measures of variations, we return to standard deviations, the range between the minimum and the maximum within our data sets, and so on. Again, for exploring data, but in a visual way this time, for categorical data, we can make use of bar charts, cluster bar charts, and so on. And for continuous data, we typically use histograms and box and whisker plots, dot plots or scatter plots if we have two variables that we want to look at jointly. This is just a simple overview of some of the things that that are usually part of the starting packaging and looking at the data. And these will be some of these things we will actually cover as we move to SPSS. And I think this is a pretty good spot to actually switch to SPSS. Now, it would be useful to know whether Merla shared the link with you, the one where you can either, so there are two ways. If you have SPSS installed, please use your desktop version of SPSS, just open it. Otherwise, what we'll do, we will actually use the virtual lab for this portion of the workshop.
I did share with everyone the link to the virtual lab, but I'll put it in the chat again, and you'll be able to find it through that. When you go there, you will have to input your NSID and your normal USask password. So just like normal, it says username and password. It is looking for your NSID password and your NSID username and your NSID password. So it'll take about a minute or so to get all that loaded up for each of you, unless, of course, you've got SPSS already on your computer, in which case you'll be good to go.
Thank you. So if you follow me via the VLab route, just know that this is quite a useful platform, not only for SPSS, so it's a virtual laboratory where the University of Saskatchewan offers several software packages that you can access. So in order to go there, as Marla just mentioned, we have to go to vlab.usask.ca. And I will say that it is not mandatory that you actually do these exercises at the same time as I do them. It might be just better, especially in the first part, for you to have a look as I describe things. And later on you can try it on your own as well. It's really up to you, whatever you feel comfortable and whatever you feel that it's making more sense. Now, as Mara mentioned, you receive this pop-up window, welcome to VLab, where you have to introduce your NSID and your password. Once you have that all set up, you can click connect. And it will take a few seconds to get that started, and I believe SPSS is under Common U of S. So here you have on the left hand side, you have a panel that allows you to navigate to the different software packages. And under Common U of S, you should be able to see down the list the SPSS 26. 26 is the version of SPSS that we have access to. You can just click on it, and that will launch the program for you. It's taking a little bit of time to install, and in case, I'd suggest if you use this in order to run your own research, if you use the virtual lab, please make sure that you always save the information, because it has been known to be a little bit buggy, and at times it can also just drop off, close unexpectedly. Okay. So hopefully you're all here with me. The first thing that you'll see is the welcome window for SPSS, but within this welcome window, you actually get a lot of information. So in this top right panel over here, you're being given some updates and features that are present in SPSS, and you can flip through them. See, they're showcasing some of them. Now you have some links here for additional support and resources. You can also get help and support by clicking on this button. So if I click on this, it will take you to the web page, to IBM's doing SPSS help and support page. And they do have a lot of useful and practical material here as well. So it is a good thing to keep in mind. You also have some tutorials that are available to you, again, great resources. And what I want to draw your attention to for now is this left side panel that has as a title here, recent files. It doesn't recognize any recent files. If you use it on your desktop version and you've worked with it, you'll see that it pre-populates here, just like any other Windows-based software package. It will populate the list of recently used items or files. But for now, because we have not worked with it, it just doesn't see anything. However, I'd like you to click on sample files. So in sample files, what you will note once you click that tab is that it populates a lot of items in your box. And there are three distinct types these are all SPSS files. And we have three different types of files in SPSS. The one that has an SAV extension, like the one that you are seeing currently here. I can also just click on the second icon next to all in order to for SPSS to only populate these SAV data files. These data files contain a database, so this is where the data is being stored. There are also two other types of files in SPSS. SPS, the ones that have this extension, are syntax files, and I'll talk a little bit about syntax files. These are ways for you to store, to save your commands, the ones that you run as you analyze your data. And that's very useful, both in terms of helping you in your research process, because they allow you to track all the steps that you've taken in the analysis, and it allows you to rerun things at once. You don't have, if you go back, after a day or so to your data set. You don't have to manually run every single analysis that you had run previously. You can use the script or the syntax to save that information, and then you can just rerun it. Now, in research, it's also very important to save this information, usually because of we work in teams, and we want to be as transparent as possible and also document as accurately as possible our research process. So the syntax, again, can be shared with others, and they can also have a look at your step-by-step process. So typically a very useful feature to have. And then the output is in SPE format. And this one looks similar to a Word document. It's where all the analysis results are being shown, and it's, again, a file that you can save. And I'll show them to you as we go to SPSS as we open. So can you please go back to the SAV ones? So you can either click on all, or you can click on the icon that has the red Excel, tiny Excel spreadsheet on it. And I'd like you to navigate all the way to the data set that's called demo. This is a data set that comes with SPSS. And I'm picking this one it's not an actual data set. A survey was not sent out, and they did not actually collect data. It's a made-up data set. However, it's useful in running through different commands and understanding how to import data, export it, and manipulate it. So I'll click on demo.sav. I'll select that, and then I can click on open. Okay. Now what that does, it's actually opening something that looks quite similar to an Excel spreadsheet. This is the database. The SAV, as I mentioned earlier, is where we store the data. Now we have in this first window that you see here, you can see a lot of information. You have several variables, and the variables that were collected or were introduced appear on the column. So each column represents a different variable, and each row represents a case. So this would be one individual of age 55 with a marital status of 1, and we'll see right away how we can find out more about what this 1 means. There's a button right here that allows me to flip between the values that are recorded and the labels of my data. So if I click on it, you'll see that it flips between values. Okay. So if you look at the marital status, we have 2 values that we see here. We see a 1 and we see a 0. When I click on this conversion icon right here, value labels, it pops out the labels of that variable. So 1 means that the individual is married, 0 means that they're unmarried. And so on. We have also information about their address, their income category, and few other things as well. The type of, here we have the type of technologies that they have at home. Do they have wireless? Do they have a multi-line, voice, a pager? Clearly the data is a little bit dated, but still useful, and so on. So these are all variables about the different technologies and technologies that individuals might have. Okay. And to mention once again, on the columns is where we store information about the variables. So these are different variables: age, marital address, income, and so on. And on the columns is where we store data about individuals. So rows is where we store data on individuals. On row one, we have the first one of the individuals in this sample. Now, if you look at the bottom of this window, bottom left, you'll see two tabs. You'll see the data view tab. This is the window that we're seeing at this very moment. And we have the variable view tab. The variable view tab is where we can see in a more summarized form the data and the description of the data that we have, of the variables that we have. And we'll work with it in just a moment. Now, you can flip back and forth between these two tabs. Of course, you can also edit things directly in SPSS. Like you can double click on cells and you can change the value of your variable if needed. You can, it has different functionalities. You can sort ascending or descending. You can run descriptive statistics directly from here on a certain variable and so on. Now, before we get into more familiar with the data set, let's have a look at these other options that we have here. Let's just familiarize ourselves a little bit with the main menu in SPSS. So we have the first menu option is file, and this one is often used both for importing and exporting data to and from SPSS. So we can create new files. So if I'm interested in filling in the information by hand directly in SPSS, I can actually create a data file. So I can click on data, and what I'll get is a new matrix. And in here, I can say, okay, I want to have a variable with the name age. And I'm going to go back to my data view. I collected data from 10 individuals. The first one is 12 years old. The next one is 13, 15, and so on. So I can put in all the values right here. And then I can use variable view in order to specify more information about this data. I won't do this right now because we already have a data set and we'll be working with that one. So I'll just close. And it's asking me, as I'm closing this, is asking me whether I want to save the changes to this data set. Clearly nothing of value here for me, so I'll just say no. So we'll return to our own file, the demo. So under new, you can create new databases. You can create new syntaxes. Okay. Syntaxes are just lines of code that you can then reuse in order to run at once all your commands. So I can click on syntax and it says, okay, please type in what you'd like to do. And we'll return to this as we run some of the analysis, and I'll show you how to use this directly. If you are versatile in coding directly in SPSS, you can just use the syntax directly and just type in the code and then just run it. Now, also from file, you can import data. The data is imported typically if it's in a different format than the native SPSS format. So unless you have SAV file, you typically go to import data. And if you have an Excel spreadsheet, and let's see if we can find one in SPSS's database. So import data, you can see that you have several options here. You can import data from an Excel file, from a CSV, from a text, SAS, which is another statistical software, Stata, again, a different one, and few other options as well. Typically, you'll have their data either as Excel or CSV. So let's click on Excel and see if we can find a data set here. Okay, so there we have it. Let's say I want to upload this data file, and I click on it. It's an Excel file. And then once I selected the file that I want to import, it pre-populates the file name, the file type, and then I click on open. And what that does is gonna take me to this new window. This new window is asking me about some specifications as to how I want that Excel spreadsheet to be read. SPSS wants to make sure that it understands the structure of your Excel spreadsheet. So it's asking me read the variable names from first row of data. Yes, it's correct. I have some headings, and in these headings, I actually have the name of the variables that I'd like to import. And then you get a preview here in this icon. And let's say everything looks, and it also asks you about the worksheet that you'd like SPSS to open your data from. So in this case, we'll just say the complete spreadsheet is the one that I'm interested in, and then click OK. And once I click OK, then what you'll note is that I have just imported that data set into SPSS. So now I have this new data set that I've just introduced, and you can see I have a lot of missing data in here. The missing data here appears like this. I just have these empty, actually dotted cells, and I can flip between data view and variable view, and in variable view I can see all of my variables at once. You can see I have 76 variables measured on different.
Anna Maria, sorry, Brianne had a question. She said, sorry, I missed that. What language of coding can you use?
So this would be, thank you for that. This would be SPSS's own specific code. So here, I'll show you quickly how that looks. So for example, if I'm interested in running, let's say, some summary stats on this variable called crop, you'll see that I just ran the analysis, but I can also go back and say, okay, don't analyze descriptive statistics and descriptives, let's say. And I'll just choose this time prime size, let's say. And instead of clicking, so OK will run the command, paste will actually paste in the text, the command in the syntax. It automatically does that for you when you do it. So as you see here, it just has its own way of, its own language that you have to use in order to specify what that command is. I believe there's also SPSS has attempted to link with R scripts and Python scripts in some of its latest editions. Yes, so if you go here to new script, yeah, I think, well, I see Python 2.3 and basics. So I think it's likely that you can just import those and SPSS will recognize them and convert them into its own syntax. So I'll just close this for now. That's a bit ahead. All right, so that's another example of opening or using an Excel spreadsheet to import the data. And now that I've imported this particular Excel spreadsheet, I can actually go to File, Export as a database. And what this does is that, I want to go to File and Save As, because I want to save it as an SAV database right now. So the next time I'm opening up this data, I want to use it directly as an SPSS database. So I'll just call it, research project. Let's say you have a certain number for this research project and then the date. And so on. And then you'll see it that it's being saved. You can request it to be saved in certain formats, but I do want the local encoding of the SPSS. And then you just need to select the location as to where you want this saved. Okay, so I can just say desktop and then save it. And then next time when I go to open this, I can just open it directly as an SPSS dataset. I don't have to go through the importing of the Excel spreadsheet. Okay, so I'll just close this new dataset that I've opened. Not interested in working on that right now. I was just showcasing you ways in which you can, whoops. Seems that the lab is making itself known. So under File, from the File menu button, you can either open new files, import data from different sources, and you can also save these new files in a completely different format. Now, there are a few other options here in editing. You have the undo, redo button, which is similar. This is quite similar, I think, in functionality with some of the other Microsoft-based, like Microsoft Office suite. Then one of the parts or one of the menu options that we use quite often is data, transform, and analyze in graphs. So under data, you have a lot of commands that allow you to manipulate the data set. Under transform, you can get a lot of data modification commands like recoding variables, renaming them, creating new variables, or computing new variables. And then under analyze, you have all the most of the analysis commands that are common in SPSS. And depending on the type of SPSS that you have, you might have a longer array of analysis options or a more constricted one. But today we'll be working with some of the commands from Descriptive Statistics, where we can look at frequencies, descriptives, we can explore a variable, and you'll see that this gives us a snapshot of the variable by running multiple commands at once. Crosstab is a way of looking at bivariate, two variables at once. Say we're interested in how education differs across gender groups. The crosstab or contingency table can be useful in allowing us to see that. And then you have a few other options here as well. Now, the other interesting options are correlate. You can run regression. You can build regression models and run them. Classification analyses. These non-parametric tests, dimension reduction, factors analysis, and so on. We clearly will stick to some of the descriptive statistics today, and then the other thing that we are building some graphs, whether they're for one variable or multiple variables.
Anna Maria,
yes.
I'm just going to get you to talk a little bit more loudly. I'm having a little bit of trouble hearing you, so just be really big.
Okay.
Okay, thanks.
No problem. Hopefully this is better. Okay, so shall we continue for about 8 more minutes? I'll show you how to organize your data, and then we can take a 5-minute break. Does that sound all right? Okay.
Yes, that's great.
Excellent. So let's go back to these two tabs. So we have the data view here and then the variable view. Now I want to have a look and see exactly what's in this variable view. As I mentioned, this gives me an overview of all my variables. In this data set, if you look on the first column, you can see that we have 29 variables, starting with age and ending with response. Now, in this first column, under variable view, you just, the name is just the name of the variable in the system. In SPSS is the way in which if you run or type in your syntax, you would have to use this particular name of the variable in order to be able to run. Okay, now it also gives you information about the type of data. So you have different options here. Okay, I'll go back there just so that you can see it. Once I click on this cell, I get this browsing button here on the right-hand side, right in the cell. So if I click on it, it opens a new window that shows me the different options for variable type. You can have a numeric one, a comma, a dot, a date, and so on, a string if you have text. But in this particular case, we have the data already as numeric because it was previously coded, and the age was probably collected directly as a numeric variable. So we'll click OK on this. And then the width refers to the width of the column, the display that you get under data view. So that is mostly an aesthetic thing in terms of how it gets displayed in the SPSS. Now, decimals refer to the decimal points that you get for your the values of your variables. So for example, if I look at age, I have 0 decimal points, but if I look at income, I have 2 decimal points, which makes sense. There's really no, it would be rather nonsensical to have decimals for the age unless you're measuring it in somehow in in years and months. Okay, but so if I go back to my data view and I have a look at this variable age, I see that I don't have any decimal point decimals that are present there. But if I look at income, for example, it does get displayed. So you see the first 2 decimal points. If I want to change that, all I have to do, let's say for the income, I'm interested in seeing 4. I just double click on that value and I change it, and then I go under data view, and I should be able to see already the notification right here. Okay. Now, so that's what this column is for. Then the labels. The labels are usually when we collect data is where we store more information regarding the variable. So it's how we know precisely what's in that. So for example, here, they don't only mention that it's age, but they specify that it's age in years. A lot of times what we have here when we run surveys is that we put the specific question that we asked individuals right in the label, so that we know precisely what was put there. So this is just the label for the variable. And now, if we look at values, is where we get information over the different levels of measurement or the different categories that are within each variable. So for age, we don't really have any categories. Age is a continuous variable, that spans from 1 to 100 plus. We don't specify those values. However, when we turn to marital, which represents the marital status of the individual, this is a categorical data. It's a nominal type of data. So what you'll see under values here, once you click on the cell and then click on the browsing back button, is that it gives you the labels, the value and the label of that value. So if I click on this, you'll see that for the value 0, we recorded it 0, the individuals that are unmarried. And for the ones that are married, we assigned a 1. That's how we coded it. So that variable marital status has 2 categories or 2 levels, 0 and 1. 0 being unmarried and 1 being married. If I want to modify this, let's say I miswrote the label for this variable, all I have to do is click on it and then highlight it or just delete that particular the label that I put, and I can rewrite it. And in this particular case, maybe I just want to write it in a different way. Maybe I don't want to use a capital U at the beginning, so I can just use this unmarried, and then I can say, okay, change it, and you'll see that it will change the variable label right here. And the same for married. Let's say I just don't want it capitalized, so I'll just use it like that, and then I'll click change, and then I click OK. And that has saved the change. If I go to data view right now, you should be able to see under marital status, where is that? Married, unmarried. You'll see them now that they're no longer capitalized. And again, this back and forth switch, value labels to values, you can see right away both the values of the variables and the labels. Going back to variable views, because there's still a few more interesting things. And if I go down the list, you'll see that different variables have different levels. So for example, income category and thousands. If I click on this, you'll see that I have 4 levels. So the first one means that that individual has earned under 25,000 dollars. The second category is for individuals that are between 25,000 and 49,000. the third category between 50,000 and 74,000, and then the last category for earners, for individuals that earn over $75,000. Okay. And so this is what we get under the value columns. And again, this is something that you typically define yourself when you have a new data set. Let's see. So if we look at gender, for example, what do we get here? So gender, we typically, so this variable, if you hover over the top of the column where you have your heading, it will just show you the name of the variable, the label, the type, and the measure. So this is a nominal variable, but the way in which it's coded at the moment is coded as a string variable. Now that is, and then if I flip between, their labels and the values, I can see that the values are actually strings themselves. They have F for female and M for male. And this will be something that we will have to correct for. Ideally, we want to have this denoted by a code. Perhaps 1 for females, 0 for males, or 1 for females, 2 for males, and so on. But that will be something that we'll do right after the break. I'll show you how you can actually modify the data that was saved in a particular way. And the reason why you want to modify this data is because it will allow you to actually run the analyses that you need if you have it coded in the appropriate way. So we typically assign codes to the different values of the variable. Now let's go back to variable view here for a second. Okay. Then missing information. So under this column is usually where we specify how we coded the missing data. In certain cases, you'll see that none, so nothing was used in order to define that missing data. But if you go here to this variable, this variable that's on row 19, internet, you see some values there. So they have they coded as missing data categories 8 and 9. So you know that if you get an 8 or a 9, in that SPSS also knows with this definition that if there's a value of 8 or 9 for that particular variable internet, it just means that that's missing data, and the program will treat it as such. So it won't take it into consideration. Columns is not, it also refers to the display and the way in which you see the data in the data view. Then alignment is also related to the text, whether you align it to the right, center, or left in data view. Now, one of the most important features of this variable view is really the measurement. And as we discussed the different types of measurements or measurement levels for variables, and it's of utmost importance to precisely define them in SPSS accurately as well. So in the case of 8, and in SPSS, I should also say that you only have 3 options. If you have continuous data or ratio data, we usually use the scale indicator to define that variable. Wherever you have ordinal data, so data that has some progression to it, some logical progression, but it's categorical in nature, like education level, income categories, wherever you have those categories that are progressive, you use the ordinal measurement type in SPSS to define it. And then for nominal, it's all the categorical data that doesn't have that order. So for example, gender, ethnicity, marital status, for example, these are all nominal type of data. And as you'll see after the break, we'll go over some of these variables just to make sure that they were properly defined before we move on to run any analysis on it. So if you want to take a short break, I think 5 minutes, just to get a sip of water, and then we can reconvene and start using some of the analysis functions for the SPSS.
That's fantastic. Yeah, so it's 10:07, so we will start back at 10:12 sharp, just so you know. So please go ahead and take a quick break. I'm going to put the recording on pause, and we'll open it back up when we come back. Have a break.
Excellent. Excellent.
And we are resumed.
Wonderful. So we were talking right before the break, and that we want to have a look at the column measure in order to see the different measurement levels that were already established for the data set. And we'll do that in just a moment. I was wondering if there were any questions this far, and I'm gonna flip to the chat in order to see if that's the case. So nothing that I can see. Then I think I'll just continue. I still have a little bit of ground to cover. Ask you to mute. Thank you very much. Okay. I'm not quite sure if. All right, so let's continue with this. We have the variable age, a continuous variable, so it was set up as a scale variable. That makes sense. Now the marital status variable, if you remember, it was saved. It was recorded as a categorical variable, whether 0 for unmarried, 1 for married. So in this particular case, the scale measurement is not the accurate way of depicting this particular variable. We want to change that to nominal. Okay, so we'll make that change. Then the address, we have years at current address. Typically, this should be a scale variable, right? So the number of years. Yes, okay, that's correct. And then we also have income category in thousands. And as you can see, this one is ordinal. So it's a categorical variable because we don't ask people, what is your precise income? What is the dollar amount that you are making on a yearly basis? We're saying, which one of these categories do you fit? So it is an ordinal variable because, as we can see, we move from under 25,000 all the way to plus $75,000 a year, but we don't have the precise information. So in this case, this is accurately depicted as being ordinal. Now, one thing that you need to keep in mind is that you can transform variables, but you can transform variables that have more information into types of variables that have less. So for example, if in your survey, you would have asked individuals to give you the precise dollar amount that they are earning on a yearly basis, then if you would have been interested in comparing across different income categories, what you would have done is to take that continuous variable, the precise dollar amount, and then split it into different income categories. Okay. So it is possible to do that. Now let's have a look in data view again. Okay. So under income, actually, if you have a look, under income, we have the precise dollar amount. So the income category was something that was done very likely post data collection. So they took the income variable and then transformed it into a categorical variable, because that might have been of interest for their research. Okay, so I hope it's fairly clear as to what we have here. Now let's try and do some data modification as well in SPSS, because that's typically something that we do. When we get a data set, we don't get it perfectly the way we want it coded. So let's take, for example, this gender variable. Now we want to use this variable to create a new one, also called gender, but that in that new variable, we want to have two levels. We want to maintain the two levels, male and female, but we want to use numbers in order to code those values. So the way to do that is to go under transform. Okay, so under transform, you have the option of recoding into the same variable, which is something that you could do, but it's not advised. Typically, you want to leave the original variable in the way in which it was recorded. So a better option and a better procedure is to record into a different variable. So we'll click on record into different variable. We'll take, and this opens a new window here. On the left-hand side, we have a panel that shows all of our different variables. So I want to navigate all the way to gender, the gender variable. I want to click on it, and I would like to send it to the right-hand side panel, and I do that with this arrow. So once I do that, you'll see that this variable, the gender variable, is present in here. Now, here I get two forms that are asking me about the output variable. So I'm asking SPSS, take this variable gender, create a new one, and name it, let's say, gender new. I'll just give it that name so that I know it's a different one. And gender n. Gender new is the label as well. I can use the name of the variable as being just gender and then gender new as the label. This depends on what system you have in doing that. So I can click on change. So what you'll see, it's saying this variable name duplicates an existing variable name. Okay, so maybe I will just put an N here so that I don't duplicate. There we go. Now, I also need to define the old and new values for this, for SPSS to know precisely how to recode this old gender variable. In order to specify that, I need to click on old and new values. This opens a new window that allows me to specify what the old values were. So in the case of females, we had an F, and I want that F in my new variable in gender new to have a value of 1. So in the new value portion of the window, I'll just click on 1, and then I'll click on add. So now here I have the specification. What has been previously coded as F in my gender variable, it will be coded as 1 in my gender new variable. And I'll do the same for M. I will ask to record the males as 0, and I'll add that as well. Okay, so all good. I can click on continue now. And once that's done, I can click on OK. Or I can click on paste. If I click on paste, what happens is that SPSS writes right away the syntax for that command. It doesn't run the command. It actually creates the script. So this is the script that tells SPSS that it needs to recode the variable gender into gender n. The variable labels for gender n are gender new. And if I select this line of code and click on the green run button here, the run selection, what you will see is that SPSS is showing you the output document. The output document is the one that gives you an indication as to what command SPSS ran. Now, if I want to actually see the variable, I didn't ask SPSS to also show me the variable. So if I want to do that, I can go either under data view, but I would have to scroll all the way to the right, because what happens is whenever you create a new variable, unless SPSS by default appends it at the end of your data set. So it has created a new variable, is a variable called gender n, which you cannot see at the moment. Sorry about that. All right. So this new variable, as you can see, has 2 levels now, 1 and 0. Now I can go under variable view and see, okay, I have 30 variables now. Before I used to have 29. It's seen as numeric. It's the label is gender new. However, I have no values here defined, so I need to actually define them manually. So in order to do that, what I'll do, I'll click on the cell and I'll say, okay, value 1 means the label for, value 1. The label for that value is female. So add it. And then 0 is for males. So add that as well. Okay. Once I do that, I can click OK. And then the other thing that I'm really interested in is that the measurement level is accurate. In this case, nominal, correct. And now I can go back under data view and I can inspect once again this variable. Yes, it looks accurate. Now, let's say, given that that's one way of modifying data, and we can spend a little bit more time here to do that, but I want to show you other things as well. However, let's have a look here. You can also automatically recode your variables, and that's one way of doing it. You can also create dummy variables. You can do visual binding with scale data, or you can rank your cases. So these are just different options in which you can modify your data. However, instead of focusing on that, what I'd like to show you is that you can actually also compute a new variable from existing variables. So if let's have a look at some of these variables here. We have the variables from wireless. So this is the whether a person has wireless service or not in their house. Let's go under variable view. I think it might be easier to see them all. Okay. Yes, there we go. So we have all these variables here. that give us an indication as to whether a person has a certain service or not. What we could do, we could just say, okay, I want to have a variable that shows me the number of services that an individual has. So what I want to do, I want to sum across all these variables that I have over here. Okay, and the way I have them saved right now is 0 and 1s. So if they have the service, they're coded as 1, otherwise they're coded as 0. Okay, good. Now, if I want to create a new variable, let's call that sum of technology. The way to do that is by going to transform, compute variable. You click on that, and then it asks you about the target variable. The target variable in this case is the new variable that you're creating that sums up all this information. Okay. In order to do to start, I need to give it a name. So let's call it sum tech. And then in here, on the right hand side, under numeric expression, is asking me to define how to compute that sum tech variable. So in this particular case, what I want to do, I'm interested in taking and adding each and one of these variables, all 13, I think, variables, in order to get the total amount of services that individuals have. Now, there are different ways in which I can do this. I can pick up every single variable. Okay, I can go to wireless. Okay, say wireless service is the first one. I click on it, I send it to this numeric expression box. Then I click plus because I want this variable to be added with the subsequent one, which is multiple lines. I do the same and so on all the way through all my 13 variables. Now that's one way of doing it, but we have the advantage here that all of our variables are one next to the other. So instead of specifying them one at a time with a plus mark between them, what I can do, I can make use of a shortcut. And that shortcut is this one. You can use the function sum. And that function sum will sum across the different variables that you specify. And because we have adjacent variables, so one column after the other, we can just indicate the first variable all the way to the last one that we want that summation to happen across. Okay, so I'll delete that. If you go under arithmetic, you should be able to see the summation function. If you, or maybe under all, but okay, I think I just missed it a few times. Going back and forth. There it is. So I can just click on sum. Okay, it says the sum is it works with numeric data, returns the sum of its arguments that have valid. So in here, I get some information as to what this function does. We know that already. So what we do, we just send it to the box, to the numeric expression box by using the up arrow. And then it asks me to define the variables that I'd like summed. Now, the first one is the wireless service. So I'll click again on the left pane and send it to the box. And I can enumerate all of them one after the other using a comma between them. Or because these are adjacent columns, I can just say wireless to newspaper subscription. So what this particular function expressed this way will take all variables starting with wireless and sum across until it reaches the variable news. And the value for each individual will then be stored on the sum tag. Okay. Once we specify this, again, this kind of formulation works in this instance because our variables are one after the other. Otherwise, we would have had to use the plus and enumerate, or use the sum function and enumerate them using a comma to separate them. Okay, once we have all this, we can click OK. And again, I'm being told here that SPSS ran this command and it executed it. Now let's have a look right here. Okay, we see the 31st variable called SumTech. And if we go to data view, we can see that it has different values. So if we look at the first individual, we see that they have 4 services. They have voice, they have, they own a TV, a VCR, a CD player. So the sum for that variable is 4, and so forth for each individual, and goes through this. Now you can note that the sum tech is by default recorded as a nominal variable. I want to change that right away because that is in fact a scale variable. Okay, great. Now let's have a look at some descriptive statistics. The way in, let's say we reported our data set, we had a look, we made sure that everything was specified appropriately in our variable view. We're happy with the way everything looks, and now we can finally start to look at our data set and understand better what's in the data that we collected. So in order to do that, we can start by looking at some of the descriptive statistics, whether that's visually or using some summary statistics. And for some reason, SPSS Virtual Lab is taking a pause. So what I want to do right now, I want to go back, if you remember this slide that I had for us over here. I want to go and look at, let's go and look at a categorical data and summarize it using some frequencies and percentages. And then we can also use a bar chart in order to look at the same categorical data as well. So let's see if the virtual lab is up to speed and cooperating. Oh, okay, got it back. Excellent. So under analyze, let's take, for example, the variable marital. We want to see the marital status of individuals. Okay. In order to do that, we can go to Analyze, Descriptive Statistics, and in this case, Frequencies. Once I click on that, it opens a new window, and this frequencies window is asking me to select the variable that I'm interested in. I can either select one variable at a time, marital status, if that's the only one that I'm interested in. I can just click on it, click on the arrow to send it into a variable box, and then I have here several options. I can look at the statistics tab. So under the statistics tab, it gives you several options. It can show you percentile values, central tendencies, skewness and the dispersion measurements, but because we're looking at a nominal variable, those are of no interest to us at the moment. So the way in which we can summarize a categorical variable is by using either frequencies or percentages in order to do that. So for now, I'll just close this, and then I'll have a look at charts. If I want, I can directly create a chart right from this window. So I can say, okay, show me a bar chart as well, or maybe it's more appropriate in this case to look at a pie chart. I think either one of these two would do just fine. We typically tend to go for bar charts as they seem more accurate in reading. Then histograms, again, would be something that we use for our scale variables. So that's fine. Bar chart is correct. And then it asks us whether we want to show the chart values as frequencies or as percentages. If you want to see it as percentages, then you just have to click on the other radio button. Then we click continue, and we can click OK. What that does is provide us with some of the summary statistics. Now, the first thing that you will note here is that SPSS gives us information regarding the variable. So we have 6,400 cases or observations that we can see over here. We don't have any missing values for this particular variable for the marital status, which is excellent. And now we have a table of frequencies, percentages, value percentage, and cumulative percentage. So it gives us that one quick snapshot of this categorical data. So by looking at this graph, this table, frequency table, we can see already that we have about 50% of our sample, so the percent is here, is unmarried, whereas slightly under 50% are married. So quite a balanced sample in terms of married and unmarried individuals, as you can note from these figures. Then the frequencies represent the number of cases. So we have 3,224 individuals in the data set that are unmarried, and we have 3,176 that are married. In total, we have the 6,400 cases that we mentioned. So we collected data from 6,400 individuals for this particular data set. Okay, then the valid percentage would differ if you had missing data. It would differ from the percent. The percent is calculated from available data, and the valid percent takes into consideration the missing data as well when it calculates that percentage. And the cumulative percentage just says that it adds the different categories. So we have slightly over 50%, so 50.4% of unmarried. And then if we look at unmarried and married, of course, we have the entire sample. We have 100% of our cases included there. And as you would expect, the graph looks, the bars on the graph are quite similar because, as we see in the table, we actually have a pretty much 50-50 split in terms of marital status in our data. Now that's one way of looking at a categorical variable, but if I was interested in looking at a categorical two categorical variables, let's say I was interested in understanding whether there was a difference in the marital status between males and females in the sample that I have, then what I would do, I would make use of some of the bivariate statistics in order to have a look at that. And a typical way of summarizing two categorical variables would be using cross tabulation or a contingency table. So if I go to Analyze, Descriptive Statistics, I can use cross tabs. So Descriptive Statistics, cross tabs. And then I can select the variables that I like summarized on the row and on the column. So now I'll have variables both on rows and columns. So I'll select, we said we're interested in understanding the marital status and as it pertains to the different genders. So for gender, I won't select the original variable, but I'll actually select the one that we created together, the gender new, which is towards the end of the list. And I'll put the gender on the column in this particular case. Now, I can go under statistics to ask for additional things. So here, you can actually run a test that is called chi-square, independent test, in order to see whether those differences between the groups in the marital status are statistically significant. I won't do that today, but because that would lead us to discuss a little bit more about inferential tests and how we have to prepare and look at the data in order to make sure that we can run those inferential tests and we can read the information accurately. But if I was interested in that, I could select this chi-square test and then click continue. So for now, I won't do that. However, I will go under cells because under cells, I can also ask for additional information to be in the table. So because I'm not running the chi-square test, in the chi-square test, we typically look at the difference between the observed and expected values, and then at the residuals, the differences between those two, between the observed and expected values, and that's one way in which we can determine whether that difference is statistically significant or not. But for now, we'll just look at, we'll just ask for percentages. So you can see here that I already get the counts for my cases, and I'll just ask for row and column percentages, and then I'll click continue. Now it also asks me if I want to display clustered bar charts. Clustered bar charts would take into consideration both variables. So in order to do that, I can just click right here, and I'll also get a graph together with the table. Okay, once I select all of this, I can paste it so that it can go into my syntax. Okay. And then I can also, what I did, I used a shortcut. So this button right here on the menu is a recall button. So you can access your latest commands that you ran. So I went to cross tab and it opens the window that I had previously opened. And instead of pasting, I'll just click OK. And that should run the command this time, and it should show me the results again. Okay, so with these cross tabs, now we get, again, quite a bit of information. We first of all have the cross tabulation. So the cross tabulation has both variables. Here we have the marital status on the rows, because that's where we asked SPSS to place it. And then we have the gender variable on the columns. Now, what you can see is that we have 1,691 males that are unmarried and slightly less females that are unmarried in our sample. We have 1,533 females that are unmarried. And if I want to look at percentages, so within the marital status, I get 52.5 males that are unmarried and 47.5 females that are unmarried. And then for the married count, again, we have slightly less males that are married and slightly more females. You can also see the depiction of this information in the clustered bar chart below. which carries exactly the same information as in the table. Now, I had mentioned to you that we could analyzing this qualitatively, just by looking at the figures, we can see that one figure is bigger than the other across gender groups. However, we cannot state with certainty whether that difference is actually statistically significant. In order to do that, we would have to run an inferential test in order to do it. And for those who are familiar with the test, I can just quickly show you how to do that. So going back to the command that we had, the crosstabs, you can click under statistics, you can select the chi-square test, and then you can also select the coefficients for that, whether it's the contingency coefficient, the phi, and the Kramer mean. And then we can also ask to get within the cells, we can ask to get expected values and adjusted standardized values. And then we can also ask it to compare across the different levels and then click continue. And what this does, it gives you some additional information. It actually runs the test as well. You can see the result of the test right here, the chi-square test of independence. First of all, we look at the notes here. We want to make sure that the minimum size for the sample was, we don't have expected counts of less than 5. That's a minimum condition in order to run the test. And then we see that the test was actually significant. And if we look within the table, we can see that it was significant at different levels. So there are statistically significant differences between males and females. We get, it's not only by chance that we've observed that difference. That difference is significant. And assuming that the rest of the assumptions for running the test are in place, we can interpret and further discuss this difference. Okay. Now, that's one way of summarizing the categorical variable, and it's usually a very useful way of looking at nominal and ordinal data, just by running some frequencies and percentages using the bar charts or the cluster bar charts, using cross tabulations whenever we have two variables that we want to look at in tandem at once. Now, of course, you can also build your graph separately, and you can do that by going to graphs, chart builder, and here you get a dialog that is saying before you use this dialog, measurement levels should be set properly for each variable in your chart. We've made sure that that was the case, so we can just click OK. We don't need to go back there. And what this chart builder does, it actually gives you all the different types. Like here at the bottom, you can see the different types of graphs that you can select from. So if we were interested in building a pie chart, then we would just navigate here. We would click on this icon and drag it into the gallery chart. And then in here we can define the variables, or we can introduce the variables that we're interested in. So I can pick up the marital status, and I can say, okay, just slice it by marital status, and go. We have a chart here, and then I can use some of these elements here, like element properties, in order to change some of the characteristics of this chart. So for example, if I'm interested in changing the colors, I can do that from here. But if I'm generally satisfied with it, I can just click OK, and what that will do, it will actually just produce that chart there for me. and I can even access the different features from here. If I double click on it, it will open a chart editor window, and here I can say, okay, I really don't want to use red for merit category, so I can just go back and say, click on this half of the pie chart and say, okay, I want to fill it with green, and then I click apply, and then you'll see that change has happened, and then you can just close your editor and the change will take effect. Now, that's a different route. If you don't want to draw your graphs and charts directly from the analysis command line. I also want to spend the last few moments in showing you how to summarize and how to look at the scale variable, because we talked quite a bit about these categorical, whether they're nominal or ordinal data, but a lot of times we use the scale data, continuous data. So in order to summarize them, we can use slightly different command. And if I go back to our data set, we can take, for example, income. So income as is recorded, as was initially originally recorded, as a scale variable. So let's say I'm interested in looking at the average, mathematical average, the mean of this distribution. And I also want to have a histogram that shows me the frequencies of these values. So in order to do that, I can go to Analyze, Descriptive Statistics, and I can just ask for descriptives. And I can just say, okay, I'd like to use household income as the variable to describe, and then I can move it with the arrow from one place to another. And then under options, it asks me what I'm interested in looking at. Am I interested in looking at the mean? Do I want to see the minimum value, the maximum, the range? Am I interested in looking at the standard deviation, so the spread from the mean that exists within this distribution? And we can just select the things that we're interested in, and then we can click continue. Now I don't have an option to draw a histogram directly from here. I can show you a different way in which you can do that, but I'm just interested in getting a few measurements that I can click directly to here. But let's say we also want to look at the price of the primary vehicle. So their car, years with current employer. Let's put several variables in here that we ask SPSS to sum up at once. Okay. And as you will see in our output, we will get a table, and that table contains all the variables that we selected. So in this case, household income in thousands, price of primary vehicle, and years with current employer. Then it gives us the number of cases with valid answers. We have answers for all of these variables. That might be another indication that this is a demo data set and not an actual data set. And since that does rarely happens with a collected data set that you have answers for all your variables. Now, in terms of the range will give you the difference between the minimum and the maximum and the minimum in your data. So the difference is over 1,107. So that's, I guess, 1 over a million. Then the minimum, we have a value of 9,000 and maximum value of over $1 million dollars of earnings. So the range just gives you the difference between these two values that you have here. And then the average, our mean is 69,000 change. And well, one thing that we might want to make sure is that this minimum was accurately recorded. So looking at minimums and maximums can also be important to understanding whether there are some errors within the data sets. They're more useful visualization techniques like box plots in order to look at outliers. So outliers would be values that are outside of the normal range. Then for price of primary vehicle, we get similar information and the same for years with current employer. Now, what we didn't get was a visual representation of this information. So let's pick up, for example, household income in thousands. Now, you have the option of either going under Analyze, and instead of using descriptives, you can use Explore or frequencies. So with Explore, you actually get an array of tests and statistics that SPSS puts through. But in this particular case, we're mostly interested in just getting a graph as well. So in what I'll do, I'll just take back the marital status variable, and I'll use, in this instance, household income in thousands, okay? And then I'll ask it to run certain statistics, like the mean, median, let's say, and continue. I don't want it to display frequency tables because this is a scale variable, so I won't get a lot of useful information, just a very long table there. So I'll go under charts and then I'll say, okay, yes, please give me a histogram as well. And you can superimpose a normal curve on the histogram as well if you want to get an idea whether you have normal distributed data or not. We will take that out for now, and we'll just look at the histogram and click OK. So with that, we get again some of the information that we requested. We requested the mean and the median. Okay, so then the histogram just shows the frequency of these different values across the 6,400 cases that we have. So this can be just an easy way of quickly glancing at your data and gaining a bit more information over it. I think we're getting close to the time, so maybe I'll just stop for now and ask if any of you have any questions at all thus far.
Yes, and you can either unmute yourself and ask the question, or you can put it in the chat. Either way. Anna Maria, I actually had a question. Can you hear me?
Yes.
Okay, good. I had some sound problems, so I wasn't sure. When you import your original file into SPSS, does it change the file, or does it save it sort of as its own SPSS file? I ask that because we had a data management a webinar a couple of weeks ago that talked a lot about making sure that you save your original data set without any of the changes to it, and to make sure that you have sort of a master data set that is not touched and does not get run through any of the programs. Could you talk about that a little bit?
Certainly. There are definitely certain procedures that we follow when research. To answer directly your question, when you import a data set, let's say an Excel spreadsheet into SPSS, SPSS will import the data set as it was saved in that Excel spreadsheet. However, as you modify the data set. It doesn't modify your original Excel spreadsheet, but it will modify the data set within SPSS. So then it depends on how you save the data set once you operated on it, once you modified it. So you can either save it as or export it as an Excel file, but in that case, you want to make sure that you save it as under a different name so that you have an indication that that's not your primary or your original data set, but a data set that you've actually modified. Typically, a very good practice is to put the date and something descriptive that gives you a very clear indication as to what you've changed. But yes, so SPSS won't change the data set that you've imported unless you save it under the same name.
Thanks, Anna Maria. I really appreciate that. It's handling data is one aspect of becoming a really good researcher and knowing what you've done and when. So your recommendation to save it for the date that you worked on it, as well as some kind of descriptor, is a really good tip.
Yes, and I would like to add to that, typically, irrespective of the type of software package that you end up using, it's always a very good practice to document very well what you did. Whether that is through the syntax or the script that you use. So with the syntax, you have an option of annotating your syntax by putting an asterisk in front of the information that in front of the code, and then you can just save that information. I'm trying to get to our syntax, so here it is. So we saved some of it. Now I can just put an asterisk in front and say this command does this, and then I describe it, and then I finish that comment with another asterisk. And that will, even if I select this and run it, it will not run the command. Sorry, it won't run the annotation. It will just stay there for me to keep an accurate track of what I did with each command line. And it's also a very easy way for others to inspect and verify your work, but also just for yourself to really know exactly where you need to go in order to change things in your process of your analysis. So the syntax alone can be a script and a step-by-step unfolding of your work. That's why it's so important. Once you have it, click on File, Save, and store it in the same folder with your updated data set and other relevant files from that working session.
That's amazing. Thank you very much for those tips. Does anyone have any particular questions for Anna Maria? I know that it was a lot to take in this morning.
Those questions might arise as you start working with it. And one thing that I can say about SPSS and all the other statistical packages, because in my work, I don't actually use SPSS all that much. We typically use R or Stata or SAS. But irrespective of the software package that you use, you need to remember that in part, as you work with it, you will find different ways and materials that you can rely on in order to learn things as you go, because it does involve a constant learning when you work with them. And then the other thing is that you note that it's very important that even before you approach the software package, the statistical software package, you really need to have a very clear idea as to how you want to approach your analysis and what you need to do before you get here, and then having a certain way of accurately storing both the data and your working process, like saving your working process and leaving footnotes for yourself along the way. It will make for less headaches and a very transparent research process as well.
And both of those are extremely important. I don't see any questions coming in over the chat, which means two things. It means that it's Wednesday morning and everyone is just getting going on their week and just sort of hitting their midweek. Please join me. Thank you to Anna Maria for being with us today. We appreciate your time. We appreciate your energy. And we appreciate the very thorough and step-by-step way that you took us through. It was quite phenomenal. There's of course always lots of thank yous coming in over our chat, and that because the SURE students are amazing for that. Anna Maria, thank you so much for giving us your time and energy this morning and sharing your knowledge. And if anyone has any questions, do know that you can reach out to Anna Maria if there's something specific that you'd like a little bit of background help on. There's also the Social Sciences and Research Lab YouTube channel that has a number of SPSS modules on it as well. This one is being recorded, and once it is processed, I will have it up on the website.
Thank you very much for inviting me, and I hope it was a very useful session for you, and I wish you all the best with your programs. I hope it's an exciting year that you have ahead of you. And yeah, as Mary mentioned, we have our website. It's a very easy way in which you can have access to us should you be interested in finding out more about our work, or should you need additional help.
Thank you all very much. Have a great rest of your day, and we'll talk to you again soon.
Wonderful. Bye.